Okay, now we'll talk about in for the primary cementing what are the new additives we are looking at for the in the primary cementing job. So first new additive that we have is the carbon nanotubes. So now we are talking about the carbon nanotubes in the methyl methacrylate polymer matrix, and it dramatically reduces the fluid loss. Fluid will not be lost like it used to be before. It increases the bonding property, so you will have better bonding with the casing as well as good bonding with the formations that you are dealing with, and it will have a better shrinkage control. For example, over time you will not the cementing will not lose its properties and so on. So there is a lot of research going on, and the research references are attached in this video. You can look at this paper where they are talking about a good hydraulic isolation between the porous rock formation penetrated by the wellbore. It also improves the tensile strength, and is very effective for the formation cement and cement casing cases. The other one additive is again silica nanoparticles in this one. So before was the carbon one, now they are talking about silica nanoparticles. This is quite effective for the gas migration, because as you know, the gas migration can happen from a very tiny channels. So this one actually helps to control that gas migration very easily. So again, there is a paper reference, it's given in the end. You can download from this lecture in the description. Okay, so in this case what they did, they created two samples, one with silica nanoparticle, one without, and they see that this could accelerate the hydration process due to its ability to provide a large surface area. Okay, so it will create a very denser and stronger cement structure which exhibits very low porosity and permeability. So basically this silica nanoparticle reduces the porosity and permeability of the cement, which in turn helps to mitigate the gas migration problem after some time. This is important because most of the wells that are abandoned 50 years ago, 60 years ago, right now they are creating problem of gas migration, and they're just very small tiny gas particles are coming emitting from those wells and creating the environmental hazard for them. So in this case, these kind of silica nanoparticles can increase the quality of cementing job and so on. Then we have another new particle additive, which is the rice husk ash. So rice husk ash basically is the waste of the paddy or rice one. So when we have the rice production, rice is covered inside this husk part. So husk is separated and the rice is separated. So this basically is a good source of silica oxide, and of course it will, if you add this one, it will increase the porosity and permeability and strength of the cement, especially when you are dealing with very high temperature wells or steam injection wells. So this one will increase the strength of the cement and so on. So this is another topic of discussion right now. Everyone is talking. Especially this serves as anti-retrogression mineral. So for example, the cement will not lose its properties for after a long time. For example, you are checking the strength of the cement after 20 years. So addition of this rice husk will keep their properties like same and so on. Then we have a new product which is called oil waste, and again this is used in Saudi Arabia with Class G oil well, and the purpose is to check the permeability, carbonation and so on. So they find out that it can reduce the permeability, and also it can increase the strength of the cement in Class G and so on. So they used it in Saudi, this one. And then another new particle that we are talking about is the fly ash, and so the fly ash basically is a low density fluid, low density additive used when you have a very weak formations and you cannot keep a very high pressure, and there is a chance that for loss circulation can occur. So in the weak formation, this fly ash can be used. So it's a very inexpensive material, used lightweight material, and it also has pozzolanic ability. So that's why it can also improve the compressive strength of low density cements. So mostly it is used when there is unscalded weak formations, so it has low density, you can easily maintain the pressure and so on. So these are the properties of the new properties that recently researchers are talking about in primary cementing. So now, what are the technological advances in primary cementing we are looking at? We are definitely looking at real-time monitoring. For example, in this case, we talked about okay. In this case, we talked about okay. We have in this video, for example, we are talking about the mud, then we are talking about the spacer, and then we are talking about the mud. We want to really real-time monitor where exactly is the spacer right now, where, for example, this level, where exactly is the mud right now, where exactly is the spacer right now, and where exactly is the mud right now, whether mud has settled down. Right now it is all based on our assumption at the surface. So what we want exact location, where exactly is spacer right now, where exactly is mud right now, and where exactly is the cement right now. So all this information real time, we want to look at it. So this is the technical advances that they are doing it. So for example, there's in the field one right now, there's no technology to monitor cementing operation without using buried sensors within the cement sheet, and also monitor the movement of drilling fluid. So we want to create such real-time measurements of cementing and so on. So this is one of the technical advantages. The other one, what we are looking at, smart cements. Nowadays we are talking about the smart cements. Okay, what are smart cements? We are looking for self-healing cements, we are looking for sensing cements, we are looking for shape volume cements, and then we are looking for control release of admixtures. So what are the self-healing cements? For example, after some time some crack happen, could be lack of some property or so on. Then like in our skin, if there is some we get hurt and something, blood is coming, after some time it self-heats itself, skin. Same what we want in the skin factor. And in this cementing, if there is any fracture happens, it can heal itself on its own. Either we trigger it from the surface or it just do self-healing. So there are two kind of healings, intrinsic and extrinsic here, this one. So intrinsic and extrinsic. Intrinsic means it just do it on its own. Extrinsic means you give heat or temperature or something, so then it fills up those cracks and so on. So this is what we are looking for in future cements. If we have this kind of issues, it can self-heal itself and so on. The other one, we are looking for a sensing cement. For example, now in your skin, if you touch it here, so your brain gets the signal image. So the same thing what we are looking for cement. So for example, if there is movement, there is a change in compressive strength, or maybe there is some fracture happen, or maybe there is a lack of bonding. So we want a sensing cement. The cement should tell us at the surface, okay, there's some problem, there's some cracks, there's some annuli, there's some gas migration. So it should gather the data and tell us. So what we want a cement which can sense, exactly like the skin. So as you touch the skin, it can sense it and so on, so on. Then what we are looking for is the shape shifting, especially when there is a low circulation and change in diameters or change in some composition because of anything. So in this case, we are looking for elastic or changing cementing, this one. So this is another smart cements. And later on, because of some reason, the temperature changed, or if the pressure is changing, so and some properties cannot be maintained, so you want to maintain it down, you want to change the property downhole. So at the moment when whatever property you set up at the surface, that's it, it's done. You cannot change any property once the cement is injected inside the hole. So in this case, what they are looking for, they want to change property downhole by doing something. So that's what is they are looking for in the cementing. So smart cements is the future of the oil wells industry. Also, we are looking for the smart cements which can tell us its compressive strength, its breaking, its bonding issues, or wherever it is going, and also the real-time monitoring. So that's what we are looking for in the primary cementing job at the moment. Thank you. Please like and support the channel. Please keep looking all the videos and support this channel by viewing this channel videos and so on. Thank you.